Okay, the pulse is propagating like this. Okay, now let me do two things. So a person is there on the ground, and let there be a person moving on the trolley with a speed of wave. Two persons are there. There's a person X, there's a person Y. There's a rope, no? We'll ask person X. What will be his comment? Pulse moving. How to generate pulse? So what I should do? I should hold one end of the rope. I should give a jerk. All of you know jerk, vertical jerk. If I just move my arm up and down suddenly, only once, this pulse will be generated and it will start propagating. It will start propagating. Fine. So this person, what he says, pulse is moving towards right with a speed v and rope points on a rope are at rest. There's a basic condition. Huh? So you take any point on a rope, there'll be a rest here for him. Okay, this points on a rope rest, again get confused. Rope is at rest. Let it be this one. So how the points will move vertically up and down. There's another thing. See, I think now, sir, you said wave. Now you're calling pulse. If I wave my hand vertically up and down continuously, I'll get a sine wave. Instead, if I wave once and leave it, a jerk, if I just move my arm vertically up and down suddenly, then a pulse will be generated. I think you can try this. That's why I told you, purchase one 5 meter rope, then you can really see all these things. These are not imaginary, they are very practical things. Now you can really understand, oh, this is what I'm studying. The conclusion will become very easy for you. You need not to struggle anything. Fine. So pulse means nothing but like a short wave energy. Means a wave of not continuous energy flow. If for a short interval of time, energy will be flowing that one. That's what the pulse we say. Pulse wave propagation also they'll call it. Okay, I'm interested. Okay, that this person X is on a ground. That one. So what will be his comment here now? The pulse is moving towards right, and the rope is attached. I think that's what natural. You will not see. Okay, we'll ask person Y. What is the state of him? For him, what will happen? The rope is at rest. What is the condition for him? What he says? The rope is at rest. Sorry, pulse is at rest, and points on a rope moving. The pulse is at rest and points on a rope move in circular path, it says. How come circular path? Okay, let's do one thing. Let's take a small element here. It's a rope only, part of a rope, that one. So for this person, this particular pulse will appear to move towards left here, and this will be the tension. Okay, able to understand now. A component of tension will act, it will make it to accelerate. Okay, let me just show this particular picture in more exaggerated form. There's a tension. There's a tension. Now, you'll be shocked if I show like this. The points on a rope, they'll appear. So what will happen to this element? The element will appear moving in a curved path for this person. Am I right? This person, how he sees a point on a rope will appear to move in a curved path. When this element is here, this will be a test. So as he approaches snow, so what he sees that the points on a rope, they'll appear moving backward for him and that in a curved path. Then as they are moving in a curved path, we will provide required centripetal force, the tension in the rope. From where the tension is come? Because the rope will be taut. I think if the taut, there'll be tension. So this component of tension, I think we know enough of such things earlier what we discussed. So let R be the radius of curvature. This is theta. Then mass of this be delta m. Then what we write? 2t sine theta should be equal to delta m v square by r. Will provide required centripetal force component of tensions. So this arc length will be very small. Theta, theta will be very small. So this will become 2 theta. Delta m, what we can write? Mass per unit length. What is mu? Or linear mass density of the rope. So this, what we write? Mu delta s into v square by r. So delta further 2 theta and delta s is the arc length. Okay, I agree this. Delta s, so what is the delta s here? No, delta s is arc length. So delta is what you can write? R into 2 theta. 2 theta get cancelled, r get cancelled. So finally I'll end up with t equal to mu v square or v equal to t by mu. Okay, this is speed of the wave. So what is telling the speed of the wave depends upon how much tension and linear mass density, or shall I say, it depends upon the inertia. What is mu? Mu is nothing but mass per unit length is nothing but the inertia of a medium. The type of material, the mass per unit length, it all depends upon the type of material. So if you go back, density equal to mass by volume, m by L, what will happen will become mu. If this is a rope, if this is a rope, this rope will have a length L and mass M. So what is the mass per unit length? Will be m by L. So can we write mu also as rho into S? So therefore the speed of the wave, what it will become? Okay, this is the expression for the speed of the wave. Getting some idea? So this is some very fundamental. You do have plenty of numericals related to this. So the speed of the wave depends on how much how taut the string is and also the linear mass density or what you can call density into area of cross section. Okay, we thought some other way, but here the speed of the wave depends upon the external parameters here, like the nature of the medium or the inertia of the medium, and also the how much of taut is the string. So these quantities are going to determine the speed of the wave. Okay, these ideas are very important. Sir, how come you brought circular motion? In the ground frame, it's quite very simple. The pulse which is here will be here. So for the person, this trolley frame person Y, the pulse will be at rest. And the points on a rope, they'll just move. Suppose say like here, if the person is moving here, how do the point will appear moving horizontal. Are you getting? Here the shape of the pulse is like this. So therefore, as the person is moving on a trolley, The points on a rope, they don't appear just moving horizontal, they'll appear moving in curved path, because since he's here, is located here, no? So therefore for him, any point on a rope will appear like this, moving a curved path. Suppose the same person is moving here, how do the points on a rope will appear? Will just appear moving horizontal. Able to analyze? The person is looking only at this particular point. For impulse at rest, any point that crosses the peak will appear moving in curved path. Means the this particular point, how do it appear? It will appear like this. I think you should have imagination in this frame. So the same person, if the same person, why if he moves here, how the points on a rope, they don't appear moving in circular path here because there's no pulse. They just move towards left. Relative velocity, go back to relative velocity. That's what I put. Points on a rope move in a circular path. And then circular path. If they are moving circular path, who will provide required centripetal force? Component of tension. Like this, already we have discussed enough number of times. I told you, at many places, the diagram like this will come and you should be in a position to recollect it back. Okay, any doubts you have, you can ask me.